Greetings and salutations. Welcome back to our residential plan review lessons. Today we're going to touch on res checks, rim rates, and manual J's, what you look for. So we're going to go ahead and start with the res check. It's going to be the most common energy form you find. And what's important to look for on these? First off, you need to review to your adopted code. In Texas, if you're in a non-attainment area, which is an area that requires emissions testing, it's kind of your, hint there that you're going to need to have the 2015 codes adopted. That it's at the proper energy code, it's in the proper location, proper type of construction. They list the square footage, glazing area, and climate zone. And if you need to find the climate zone data, that can be found in Chapter 11 of the IRC, or the residential section, Chapter 3 of the IECC. Designer, contractor, address, all of these reports need to be address specific so you can tie them back to the residence that they're at. And then that it passes code and that you have your values in here. So as we touched on in the previous video, the common insulation value for a batten blow house will be R38 and R13 in the walls. Now if you have a foam insulated house, and I'll try and find an example of this, you'll have what's called a cathedralized ceiling or slope ceiling, and your maximum R value general would be at 26. Most foam insulators only let you put a certain amount of inches of foam that they can verify as an effective R value. Or they have an installation standard that limits you to X amount of inches. Closed cell foams generally 2 to 4 inches. Open cell foam can sometimes be up to 8 inches. I've seen some applications up to 12 inches. Your maximum SHGC in climate zone 2 is 0.30, so you need to make sure your SHGC is lower than that. And your U factor is 0.5, or actually, 0.35 apparently in this area. It was 0.3, I guess it's been revised a little bit. And 0.5 for your U factor. You need to make sure that these numbers are lower than that. Lower is better. And SHGC and U factor, that's a solar emittance of the window. Lower is better in a low climate zone like ours. Higher is better up in a cold climate zone, so you get more radiant heat in the winter. And U factor is essentially just the inverse of a R value. Little bit of interesting information there. Now, you're required to have name, signature, and who prepared the document. Some cities require that these are prepared by an energy certified person through IRC, a ResNet rater, BPI certified individual, or architect and engineer. Not all cities require that. But if yours does, look through your recommendations. Now generally this checklist is more so for the field inspector. You should be able to pull this up in the field, and this is kind of what you would look at for an energy walk. Since we're not really addressing inspections in this series of videos, we're not really going to touch on these checklists. However, as an inspector, you need to have this at final in the electrical panel. It needs to be signed off and all of the items need to be filled in. This is required by code for the customer to see that their house meets these minimum energy standards. So we'll move on to the manual J. Per TDLR, you need to have an address-specific manual J. And the reason that the manual J is required, it's been the energy code since 2000, it's been the mechanical code since 2000. But when the state of Texas adopted the 2009 and then subsequently the 2015 code, TDLR took purview over these. And it's actually a state requirement that you gather these with all of your residential plan reviews, or any AC change out that resulted in more than 25% of the ductwork being changed, or any HVAC change out that is an increase or a decrease in the amount of tonnage from the original system. And why these reports are important is, let's say that you have a 2,000 square foot house and you have 14 tons of AC in it. What ends up happening is that you have high relative humidity, which grows mold and moisture. The black mold that you heard about in the 1990s was largely caused by overly tight houses or way too much AC. And AC has to cycle a minimum of 15 minutes for it to dehumidify a structure. And if the AC is too large, it won't cycle, it'll short cycle, it'll wear out, the AC system will prematurely fail, you'll have indoor comfort issues, and you'll most likely have mold and moisture issues. Manual J's are one line of defense that keeps that from happening. So that's kind of why you look for these, other than the fact that it also can carry up to a $2,000 fine for everyone that's missed for your municipality. And you'll look for semi-tight construction generally, anything that's modern construction. The semi-tight designation will be between 3 and 5 ACH, which are air changes per hour. So when you see those blower door forms out in the field as an inspector, you'll see roughly how many air changes per hour occur at a house. Tight houses are usually below 3.4 air changes an hour, where you reach what's considered the building tightness limit, and you need to introduce fresh air into a house. We need to get back on track here. I'm not teaching a building science class for energy conservation. So as we touched on the summary video, every time that you receive one of these, they need to be complete. You have to have your AC systems listed, you have to have your efficiencies, your sizing, and it needs to make sense. So normally a gas system will actually be a larger size maximum kBTU. You'll see most systems around 5.5 tons of potential heating ability. What they'll do is they'll adjust the blower fans per AHRI matching, and you'll have an AHRI reference number to meet efficiency standards. And certain systems pair well with each other per AHRI, and you get to get credit for a higher efficiency system. And then basically you'll look for your heating, your cooling loads. As a city reviewer, you're not going to understand most of this unless you have an HVAC background. What you're going to focus in on is the square footage, the complete information, the construction type, how many fireplaces are, because that actually heavily impacts this, and the address, builder, and plan number. Most of this other information, like latent cooling and sensible heat, you're not going to really be concerned with verifying all that information. There is a certain expectation of, I guess, preparation and expertise from your HVAC contractor. Now, per state law, there's only a few people who can prepare these. So homeowners cannot prepare them. City inspectors cannot prepare them. You have to be licensed through the state of Texas as an HVAC contractor. You have to be a resident rater or BPI certified person to prepare one of these, or a Texas registered engineer architect, MEP engineer, structural engineer. The law just states Texas registered professional engineer. One of those needs to be the person who prepares this. The other thing you need to make sure is that's the 8th edition or newer. You're not going to find a 9th edition. ACCA hasn't released a 9th edition manual yet. That's the long and short of a res check in Manual J. We're going to see if we can go ahead and find a rim rate real quick. Normally, rim rates will be utilized by Castle Rock, I believe, uses them. Highland Homes uses the rim rate. Let's see. And maybe Perry Homes. Ah, there we go. Perry Home. Let's see that energy report real quick. So this is a rim rate. This is a different type of energy calculating software than ResCheck. It's actually a little bit more in depth. And there's a few more things to look for on here. And of course, you'll verify your square footage between your reports. You pull up the manual J, pull up the rim rate. Some manual J's will have like a whole house where you won't find the cooling equipment data. You'll have just the overall square footage for the entire house. And then you'll need to scroll further down to verify the equipment and size. And some of your submitters, like LNS Mechanical, will generally include the garage and the conditioned square footage. That'll throw off your calculations. So if you're just looking raw number to raw number, 2035, and then you see 2,500 square foot, that'll put you on edge and sometimes have you kick these reports back without kind of digging deeper. So Perry specifically, you need to factor in the garage, which then puts the variance around 100 square feet. So on a 2-story house or a larger house, up to about 150 square feet is what you should be kind of allowing for a little bit of wiggle room between the two reports. And the reasoning behind that is some people measure to the interior wall surface, some people measure to the exterior wall surface, and that can, over enough linear feet, can be about 120 square foot of difference. So that's kind of a Perry specific thing that you're going to be looking at, but we're going to go back to the rim rate. So for the rim rate, one reason people like to use the rim rate is it allows you to have more flexibility. It's what's called a performance path. So earlier we were saying R38 would be required on the ResCheck. On a rim rate, it'll actually factor in more efficient AC and windows and everything else, and you do what's called equipment trade-offs. So you can lessen some of the requirements by having more efficient energy items in the house. So you can use an R30 blown if you have like a 16-SEER AC, for instance, on the software. On your above grade walls, and this is more of like a specific thing to like New Leaf homes, sometimes Highland will add continuous insulation, or like a garage wall will say like continuous insulation of an R11. Those are insulation values that don't make sense. The software itself actually gives you credit for continuous insulation of your exterior sheathing products and your interior sheathing product of sheetrock. Adding extra continuous insulation isn't required, but if you do notice that it's there, let's say they have foam board and you have a continuous insulation of R3 plus your 13, or if you have red T-ply be 0.17, green T-ply is 0.14, blue T-ply is 0.22, if you really have someone that wants to parse it out. This will require that you have a little bit of knowledge of what's going on in the field. So if you know that your builder uses green T-ply in the attic walls and they're calling out red T-ply, then you're going to have the issue of essentially double dipping your energy requirements. And Windows read about the same as the rest of the ResCheck. You just look for your maximum values. There's a whole lot of information to go through. What you're going to be looking for is if it passes the amount or passes the code. So you'll look for the cost compliance, you'll look for proper insulation values, and you'll make sure that all these sections pass. So essentially right now we have a good rim rate. This is a good example of a rim rate. And also you'll want to verify all of these values in the field. Another thing rim rate will allow you to do is duct insulation trade-offs. So pay attention to this out in the field. If you notice you have some areas that would normally require an R8 duct for prescriptive path, which is just reading the table and finding the insulation value for that location, but you have a report like a rim rate, you can actually take into consideration the performance path. You're supposed to take into consideration the performance path and allow for stuff like R6 ductwork trade-off, stuff of that nature. And this is about the long and short of reading your ResChex rim rates and manual J's. If you have any further questions, reach out to me at stoplogic1313 at gmail.com. Have a great day.